All right, let's break down one of the most powerful, but honestly one of the most misunderstood features in all of serverless, AWS Lambda Concurrency. By the time we're done here, you're going to know exactly how to control it to build apps that are faster, way more reliable, and a whole lot cheaper to run.
So to make this all click, let's start with a really simple analogy. Think about a restaurant. If 10 people walk in at the exact same time and all order a steak, what do you need? Well, you need 10 chefs, right? All working in parallel. That idea, handling a ton of requests at the same time, that is the absolute heart of Lambda concurrency. So in tech speak, concurrency is just the number of parallel copies of your function that are running your code all at once. And just like every customer gets their own chef, every single request that comes in gets its own totally dedicated execution environment. It's a simple one-to-one deal. One chef, one meal. One Lambda instance, one request. Now, to manage this whole serverless kitchen of yours, AWS gives you two incredibly powerful tools. I want you to think of them as two different managers, and each one has a very specific job when it comes to controlling how your functions scale up and down. First up, you've got the guarantor, reserved concurrency. Its whole job is to set aside a specific, dedicated number of your chefs just for your most important function. This guarantees it can always take orders, no matter how chaotic the rest of the kitchen gets. Now here's what's so cool about reserved concurrency. It does two really powerful things at once. First, it guarantees at minimum capacity by creating a kind of private lane for your function. But it also acts as a maximum cap. This is an amazing safety feature. It protects you from some buggy function that might otherwise try to scale to infinity and rack up a massive bill. And the best part? It costs you absolutely nothing to set this up. Okay, your second manager, this one is all about speed. Say hello to provisioned concurrency, or as I like to call it, the cold start killer. Its entire mission in life is to get rid of that annoying little delay you sometimes get when a function hasn't been used in a while. Yeah, this is all about raw performance. Provisioned concurrency basically pre-warms a bunch of your function instances and just keeps them on standby, ready to go instantly. In the result, you get these blazing fast, double-digit millisecond response times. It's perfect for things like user-facing APIs, where every single millisecond matters. Now, here's the trade-off. You do have to pay to keep those environments warm and waiting. So when you put them side by side, the difference is crystal clear. Reserved concurrency is your go-to tool for safety, for guarantees, and for keeping costs under control. Use it to protect your most critical backend functions. Provisioned concurrency, on the other hand, that's your paid performance booster. You use that when you need to guarantee a snappy, instant experience for your users. Okay, this isn't just theory, right? These controls were literally designed to solve some common and frankly very painful real-world problems. Let's walk through two classic scenarios where these things become absolutely essential. I want you to picture this. You launch a huge flash sale. Traffic to your website just explodes. And your Lambda function, it does exactly what it's supposed to do. It starts scaling up like crazy to handle every single user request. And then, boom. Suddenly, you have 5,000 parallel instances of your function, and every single one is trying to open a connection to your database at the same time. You know what happens next? Most traditional databases just can't handle that kind of connection storm. They fall over, and they take your entire service down with them. But here's the elegant solution. By setting a reserved concurrency of, let's say, 50 on that function, you've just created a safety valve. It's like a circuit breaker. No matter how much traffic you get, your function will never scale beyond 50 concurrent instances, which protects your database and keeps your entire application online. It acts as a perfect bulkhead. Now, for problem number 2, this one happens because, by default, all the Lambda functions in your AWS account share from the same pool of 1,000 concurrent slots. Now, this is usually efficient, but it can lead to a really nasty issue we call the noisy neighbor problem. And this right here, this is the nightmare scenario. Imagine you have some non-critical, maybe a little buggy function that goes into an infinite loop, and it just eats up all 1,000 of those available slots in the shared pool. Then, a customer tries to buy something. Your critical payment processing function tries to run, but there's no capacity left. It gets throttled, it's blocked, the payment fails, and you've just lost a sale. This is where reserved concurrency is just so brilliant. By assigning a dedicated slice of concurrency to your payment function, you literally carve out a private lane from that main pool. That capacity now belongs to your payment function and only your payment function. The noisy neighbor can scream and choke all at once in the shared pool. Your critical service is completely protected and stays online.
Okay, you gotta lean in for this next part because this is a real pro tip.
Understanding the difference between concurrency and actual throughput is a total game changer. Trust me, they are not the same thing.
So many people fall into this trap. They think, oh, I have 100 concurrency, so that means I can handle 100 transactions per second. But look at the formula. There's a second critical variable in that equation, how long your function actually takes to run. And this chart just shows the mind-blowing impact of optimizing your code. I mean, look at this. With the exact same 100 concurrent instances, a function that takes 1 second to run gives you 100 transactions per second. But if you optimize that same code so it runs in just 100 milliseconds, your throughput skyrockets to 1,000 transactions per second. The takeaway is huge. Making your code faster can be a way more effective and way cheaper way to scale than just begging for more concurrency. And finally, let's just quickly run through the hard limits you need to have in the back of your mind when you're designing your systems. Think of these as the rules of the road for Lambda scaling. The big number to know is that default regional concurrency of 1,000, and yes, you can ask AWS to increase that. Also check out the scaling rate. A function can burst up by 1,000 new instances every 10 seconds, which is incredibly fast. And this last one is really important. The unreserved buffer. AWS always keeps 100 slots in reserve just for functions that don't have any reservations. It's their safety net to help prevent one bad function from causing total gridlock in your account. So here's the real takeaway. When you master reserved and provisioned concurrency, you stop just reacting to traffic. You start conducting it, like an orchestra. You get precise control over performance, reliability, and cost. So the question this leaves us with isn't really if you should use these controls, it's how strategically can you apply them to build some truly amazing, resilient, and efficient serverless applications.